morning to one and all. For a long gap, I hope I will continuing that amines chapter. In the last video, we have discussed about preparation of amines. In those preparation, two main important named reactions. One is said to be Gabriel-Thallamide synthesis, another is said to be Hoffman's bromide degradation. Among these two preparations, one I will repeat once again because there is a small mistake. That mistake is said to be addition of ethanolic KOH. Just to observe that reaction, thallamide. That thallamide formula is said to be C double bond O and it is NH, C double bond O NH, sorry, C double bond O NH. Now this reacts with KOH. It is in ethanolic condition or ethanol. There is a possibility of removal of H2O and remaining is nothing but there is a salt C double bond O and NK. This is said to be potassium salt of thallamide. Its name is thallamide. And this is said to be potassium salt of thallamide. Now that undergoes, I will take once again C double bond O, C double bond O and this is N and K. It reacts with alkyl halide. This alkyl halide must be aromatic. Sorry, alkyl halide must be aliphatic. You may take this is in bracket. Now there is elimination of KX and remaining is said to be C double bond O, C double bond O and this is said to be NR. It is said to be N-alkyl thallamide. Its name is N-alkyl thallamide. Okay. Now that is treated with alkali is sodium hydroxide NaOH. Now it becomes, you can say that the product is C double bond O, ONA and next this is C double bond O, ONA. This is minus and this is plus. Okay, after treating with alkali, this N-alkyl thallamide, it gives this type of salt, it is sodium thallamide and main product is said to be, I will take that as R, remaining is R and EH2. REH2. This is, sorry, RNH2. RNH2. This is said to be primary aliphatic amine. By using this Gabriel-Thallamide synthesis, only you have to synthesize primary aliphatic amines, not primary aromatic amines, because that primary aromatic amine indicates benzene ring. This benzene ring undergoes electrophilic substitution rather than nucleophilic substitution. Therefore, this one step we have jumped in the last video. Hence, you have to practice this reaction and this is the confirmed reaction. Okay. So, just to note down this primary aliphatic amine synthesis by using Gabriel-Thallamide synthesis. And there is no question of Hoffman bromide's degradation because it is said to be by taking amides that reacts with bromine. That bromine is taken either in case of aqueous or ethanolic condition and sodium hydroxide. Now it gives that product is said to be primary amines, either it may be aliphatic or aromatic. Yes, so Once again I will represent that reaction also. It is very simple. That reaction is known as Hoffman's bromide degradation. That reaction is C double bond ONH2. Already we have discussed in the last video. This is taken NaOH. This is either aqueous or it can take alcoholic. Now the product is said to be degradation, means carbon is said to be reduced. RNH2, this is primary amine, plus remaining is said to be Na2CO3. Na2CO3, and next is said to be 2NADR, plus remaining is H2O. They are said to be balanced. So this equation is also we have discussed. Come to know today's class or today's video, we will discuss some properties. That properties, one is called as physical properties. Physical properties. So as usual, organic compounds, whatever it may be, you have take. First main property is said to be which is in lower member. Those lower members are said to be usually gases. As the molecular formula goes on increases, they are becoming liquids and gases. And which are said to be lower members, they are said to be soluble in water. They are said to be soluble in water. In this case also lower member amines are said to be soluble in water. And next very important one concept is said to be there are about primary, secondary and tertiary amines are there. Among these, primary and secondary are said to be having intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Why these are having intermolecular hydrogen bonding? Because there is one electronegative nitrogen atom and another is said to be hydrogen atom. Definitely between those two elements there is a formation of hydrogen bonding. Hence in case of primary and secondary, nitrogen as well as hydrogen is there, but in case of tertiary there is absence of hydrogen. Hence in this case no intermolecular hydrogen bonding. Let I will represent primary amine, how it undergoes or taking place intermolecular hydrogen bonding. I will represent primary amine, that is H and H. And another molecule I will represent, this is also primary amine. Okay, definitely RNH2 primary amine. There is a nitrogen and there is a hydrogen. It is said to be electron donor or electronegative atom, and this is said to be hydrogen atom. There it takes place intermolecular hydrogen bonding. You can continue that list or I will take another one. Molecule. This is said to be primary amine and there is intermolecular hydrogen bonding. Okay, so this concept is said to be somewhat important. After that we will move on some important chemical properties. Before that I will discuss what type of amines, whether they are acting as acids or bases or neutral. Just I will in detail discuss about the nature of amines. Somewhat it is important concept. That concept is said to be nature of amines. Amines nature is said to be usually I will take basic in nature. Why amines are said to be basic in nature? Why amines are said to be basic in nature? Because in case of amines there is a nitrogen atom. This nitrogen atom is having a pair of electrons. If these pair of electrons, these are always said to be donating electrons, hence its nature is said to be basic. As well these are called as nucleophiles or these are called as Lewis bases. These are called as Lewis bases or act as Lewis bases. Due to this nature, or you can say that these are said to be reactive in nature, or amines are said to be involving in chemical reactions. Why? Because these amines are having a pair of electrons. They act as basic in nature, or they are said to be nucleophiles, or said to be Lewis bases. There is a give and take process is taking place, hence these are involving in chemical reactions. Okay. In general, again, basic nature, if you consider what happens, acids and bases, they are definitely reacts with each other forming salt. How these amines are also acting as bases and how react with acids forming salts. I will take some reactions about basic nature. Reactions about basic nature. Acids react with acids plus bases forming salts. Let I will take for example as R, N, H2. RnH2. I will take one mineral acid HX. HX. Okay, this I will take as acid. This is said to be base and a lone pair of electrons. This is said to be a proton. Hence, this proton is said to be bonding with nitrogen. Now it becomes what happens? R. NH3, it gives electrons to that proton and becomes NH3 plus, and this is becomes X minus. This is known as one part is plus, another part is minus, hence it is said to be ammonium salt. Okay, so this is of one general example. I will take aromatic amine, that is aniline. It also reacts with HX, mineral acid. Definitely the product is said to be anilinium salt. NH3, X minus and N plus. This is known as anilinium salt. Okay. So these are indicating that amines are said to be bases and HX acid react each other forming salt. Acid base giving salt. Okay. So I will confirm one more thing. That thing is said to be if there is acid, it undergoes dissociation giving H plus. We already discussed many a times. Like that, amines also, they are undergoing hydrolysis giving bases, hence there we are measuring their Kb value. What is that Kb value? If it is higher, what the nature of this these amines are taking place, we will discuss. That means it is supposed to be taken as practical aspect based on Kb. Based on Kb or pKb values. Okay, I will take amines, that is RNH2 undergo hydrolysis. Hydrolysis means react with water. There is a proton and OH minus. Proton, definitely it is bonding to nitrogen, or nitrogen is giving electron to that proton, making a salt, that is RNH3. This is a plus part and remaining is said to be OH minus. Take its dissociation constant, that is Kb, is equals to, that is RNH3 plus and OH minus. Now remaining is said to be reactant side RNH2, a pair of electrons, and next is said to be H2O. Now we are considering this H2 as liquid in state, hence it is negligible. Therefore, I will represent this as simply K. I will take K and K dash. I will represent this as a constant K dash, K dash. Now it becomes RNH3 plus, and next is said to be OH minus divided by RNH2. Okay, or you can say that K dash is nothing but I will take KB RNH3 plus and OH minus divided by RNH2, lone pair of electrons. By using this relation, we have to measure the value of Kb by experiment. Kb indicates dissociation constant of base. Dissociation constant of base. Okay. So you have to remember in this case, higher the Kb value. Higher the Kb value. If Kb value is higher, what happens? It's pKb value, or they are reciprocal to each other. Kb and pKb are reciprocal to each other. Lower or smaller the pKb, stronger is the base. Stronger is the base, definitely. Higher the Kb value or lower the pKb value. How Kb and pKb are reciprocal to each other? You know that in first year equilibrium, that is P H is equals to negative logarithm to the base 10 of H plus. Definitely negative is there, hence pH and H plus are reciprocal to each other. Like that, pKa, pKb are reciprocal to respective dissociation constants. Yes, this point is to be noted. And similarly, one more point is very important, which are said to be aliphatic amines. Aliphatic amines. Aliphatic amines are stronger bases than aromatic amines. Why? This is because in case of aliphatic amines, there are plus I effect is taking place, but in this case aromatic amines minus I effect is taking place. Due to inductive effect, the aromaticity, you can say that basic nature is said to be changes. Plus I effect indicates there are some donor groups CS3, C2H5 and so on. If there are electron donor groups are there, basic character goes on increases. Electron withdrawing groups are there, you can say that basic character is said to be decreases. Hence, these are said to be about the amines physical properties and basicity or basic nature of amines. Okay.